So for this week's problem, we have the figure below takes the shape of a flower such that the side length of the regular hexagon ABEFGH, which is in the middle, is 2, and the height of the rectangle stem is 12. If the angle of the curve of each petal is 240 degrees, find the total area of the flower. So first, we can start by finding the area of the stem. The area of the stem is just a 2 by 12 rectangle. So it's 2 times 12, which is equal to 24. Next, we can find the area of the hexagon, horribly drawn, and it has a side length of 2. To find the area of a hexagon, we split it into 6 equilateral triangles, and each equilateral triangle has an area of the square root 3 over 4 times 2 squared, since the formula for the area of an equilateral triangle is square root 3 over 4 times s squared. So this is equal to square root 3. And now since each triangle is square root 3, the entire area of the hexagon is 6 square root 3. Next, we have to find the area of the petals. So we have a petal like that. And since this shares a side with the pentagon, it has a length of 2. And if we say the center is here, for example, we have that. And then since this angle is 240 degrees, the triangle here is just looks like this, with this being 120 degrees because 360 minus 240 is 120. Now, if we draw the height here, this is 60 degrees since half of 120 is 60, and this is 30 degrees. So since the entire thing is 2, this part is 1. So since it's a 30, 60, 90 triangle, this is 1 over square root 3, or square root 3 over 3, and the hypotenuse is 2 square root 3 over 3. So now, in a single petal, we have the triangle. We'll call that section A, and we have the sector, which we'll call section B. So section A is just the triangle, which is just half of the base times the height, and we know that the height is square root 3 over 3, and the base is 2. So this is equal to half times 2 times square root 3 over 3, or square root 3 over 3. And the second part, B, is the sector of angle 240 degrees. And we already calculated the radius, which is, so the radius, which is 2 square root 3 over 3. So then that means that the area of B is equal to 2 square root 3 over 3 squared pi, which is the area of the entire circle. And since we're only taking 240 degrees, we 2/3 that, since 240 over 360 is 2/3. And this is equal to 4/3 pi times 2/3, or 8/9 pi. Now we have to add all of these up. So for one single petal, we have 8/9 pi plus square root 3 over 3. Since we have 5 petals, we multiply this by 5, and then we add the area of a hexagon, which is 6 square root 3, and we add the area of the stem, which is 24. And then this is equal to, if we expand this part, we get 40 over 9 pi plus 5 square root 3 over 3 plus 6 square root 3 plus 24. And this is equal to 40 over 9 pi plus 23 square root 3 over 3 plus 24. And this is equal to 40 pi plus 69 square root 3 plus 216, and that's our answer.